we're going to solve this equation. And an equation like this that has square roots in it, we want to solve by squaring both sides, which will help eliminate the square roots. So on the left side, when you square the square root, that's just going to cancel out and leave a 2x. And we don't get a nice cancellation on the right side because the whole side is not underneath the square root. And again, we're squaring each side. So I have parentheses around the whole entire side to indicate that. And squaring this side means multiply everything there again by itself. And that's what you see down here. So that whole entire right side multiplied by itself. And I'm going to walk through this. I'll use the FOIL method. Most people are familiar with that, but we're basically multiplying two binomials here. So you take the first term times the first term. So for FOIL, the F, first times first, and you get this result. Basically, the square root would cancel out. We're basically squaring this term since we're multiplying it by itself, so the square root cancels out. So there's the F in FOIL. And the O in FOIL is the outside terms, so minus 4. These are the two terms on the outside, so minus 4 times that gives you that second result. The I in FOIL is the inside terms, so that times that inside term. And then the L in FOIL is last, so negative 4 times negative 4, and you get the plus 16. So now we've squared both sides. Let me scroll down here. We're just going to do some simplification. So minus 4, that's a total of minus 8. And then we had a plus 16 and a plus 16, so that's a plus 32. And then I'm going to combine the x terms. I'm just going to subtract 4x from both sides, and you'd get a minus 2 then on the left side. And lastly, I'm going to need to repeat the process because I still have a square root. So I'm going to need to square both sides again to get rid of this lingering square root. So I'm going to minus 32 from both sides to get the square root by itself. And I highlighted this line in red. I will come back to it at the end and explain a little bit of a simplification you could do at this step. But for now, we're just going to proceed. I've got the square root by itself. So now when I square both sides, there should be no square roots left. So let's see that in action. Let me scroll down here. So I'm squaring that entire side and squaring that entire side. And again, squaring means multiply everything you see by itself. So FOIL again over here, you would end up with this when you do first, outside, inside, last. And here we just have two terms. There's no separation of terms like we have over here by subtraction or addition. So we just have this term multiplied by this term. So multiplying that all together, the negative 8 and negative 8 is a positive 64. And this bit multiplied by the same exact thing, squaring a square root will cancel out, and you'll just be left with that. So the square root is gone, which is what we wanted. So from here on, it's simplification. We finally got rid of the square roots. Over here, I'm going to add the 64x's to get 128x. And distribute over here 64 times 4x and also 64 times 16 to get those two results. And you'll notice we have plus 1024 on both sides. So if you subtract that from both sides, you're just left with this line. And now I'm going to subtract 256 from both sides. And when I do that, hold on. When I do that, I get to here. And if I factor out an x from both sides, I'm left with this. And I'm using the factor property here to solve this. So I factored this down. You could have also factored a 4 out. I realize that, but it's fine if you just solve this. You'll get the solutions. These two things multiplied together equal 0. Well, one of them has to be equal to 0. So if this factor is equal to 0, then x is 0. or this factor could be equal to 0. And if you solve that for x, if you put a 32 in there for x, it would make this factor equal to 0. So those are your two solutions. X is either 0 or x is 32. And then again, we solve that. We had to square both sides. And we had to do that twice because after the first time, we still had a square root left. Now, a couple of things that could make this problem a little easier you want to look for. It may make it a little bit simpler. The numbers a little nicer. If you move the 4, add 4 to both sides to start. Just because this square root's a lot smaller than that square root, and so when you have that lingering square root, you'll still have to square the whole thing twice like we did. But it'll be a little bit nicer because this square root, as you can see, it's just 2x. Well, here we had a 4x plus 16. So if you want to try it doing that method, you're still going to go through, square both sides, and get to a point where you have to square both sides again. But I think you'll find the arithmetic a little easier if you put that lingering extra number on the side with the smaller square root. And the other tip, I said I'd revisit this red equation. Notice how everything here is an even number. So everything's divisible by 2. You can just get a little bit smaller numbers if you go ahead and just divide everything on both sides by 2. And make sure you divide every term by 2. And I also multiplied every term by -1 then, so I'm dealing with positives instead of negatives. And the steps from here, I'm not going to go through everything as slowly as I did above. But I'll show it here on the screen. You're just going to square both sides again, but now we have a little bit smaller numbers. And they're positives over here, so it can be just a little bit nicer, a little easier to work with. And you see we don't have that number in the thousands. The biggest number we get is 256. And then we follow that same procedure. We use we factor it, and x is either 0 or x is 32.